Hello, welcome to Pakibi TV. In this video, I will explain the characteristic of logicality in mathematics. I call it necessity. Logicality is the essential reason why mathematical knowledge is necessarily correct. Additionally, it is important to always remember that mathematics has the characteristics of universality and systematicity. I will briefly mention related content for a second. Even if you haven't watched the previous videos, it won't be difficult to understand. But I explained the basic content in the previous videos. In this video, what is math? I explained that math is a science that studies patterns or regularities. And in this video, what makes math important? I explained three characteristics of math: universality, necessity, and systematicity. It's a short video, so if you have time, please take a look. One takes about 8 minutes, and the other takes about 5 minutes. Here, I will explain necessity, and its core is logical reasoning. Necessity and logical reasoning are also connected in relation to patterns. The power of mathematics is based on logic. So, what is logic? Why is mathematics always correct? Because it is logical. The essence of mathematical logic is repetition of same statements. If same statements are repeated, they are what they are. So there is no room for error. However, there is a problem that it seems to have no content. Surprisingly, mathematics reveals new and complex truths even when repeating the same statement. Therefore, it is logically and inevitably correct, while its content is infinite. Once you feel this point, mathematics suddenly becomes attractive. We can draw the mathematical hierarchy like a network using a triangle, which I will call the math triangle. At the top, there are several very simple and universally indisputable facts, patterns, called axioms. This figure only shows one, but there are usually more than three. These patterns are combined logically to create new mathematical facts, which are patterns. This logical combination is called deduction. A conclusion reached logically, whether it's one step or two steps ahead, is referred to as a theorem. Such a theorem is a mathematical formula. Due to the logicality of mathematics, all mathematical knowledge should feel obvious. And if understood correctly, many aspects can become obvious. Take mathematical formulas, for example. If understood well, every simple formula feels like, isn't this obvious? Why do we need a formula for this? You should be able to think to this extent. Examples of this include the first cosine law, log calculation rules, and basic differential equations. If they don't feel obvious, then you haven't truly understood math. You've merely memorized it. For instance, in trigonometry, the definition of trigonometric ratios is at the top of the triangle. This leads to the Pythagorean theorem's trigonometric expression, which should feel obvious. It's just the same thing rephrased. Moving further, we come across the addition formula for trigonometric functions. This is difficult to feel obvious at the high school level, so it becomes a matter of memorization. But for math majors or researchers, they must visualize it in their minds until it feels obvious. This is similar with thinking about the matrix of rotational transformations. Of course, we'll discuss this in another video on trigonometric functions. In the history of mathematics of the year 2000, mathematicians have clearly established the nature of this logical reasoning. Logical reasoning corresponds to the deduction in this picture, and it is therefore an absolutely certain way of going from one thought, an axiom, to a new thought, a theorem. This logical reasoning is summarized in the modern syllogism. This can be expressed in words as follows. That is, from P and if P then Q, we derive Q. For example, from aliens are invading Earth, and if aliens invade Earth, there will be war. We derive there will be war. It may seem like we're repeating the same statements over and over, right? As I mentioned earlier, this is a characteristic of logic. Repeating the same words does not make them wrong, but it may feel as if there is no content. However, in fact, our thoughts are advancing carefully, step by step. It can be likened to tapping a stone bridge and crossing it carefully. This can be represented in a picture like this. As you can see from the picture, we started from point P, used if P then Q as a connection, and ended up at Q. If you repeat this, you can continue from P to Q, then to R, and so forth. And there's one important thing here. In logic, most of the symbols used are essentially blank spaces. These are blanks that can be filled with any content. I drew it this way to make it look like that in my explanation. In other words, logic is also a pattern or regularity. In a way, this is an obvious statement. I'm repeating myself right now. This means that my explanation is logical. Next, there are three more fundamental laws of inference than the modern syllogism. These are the law of identity, law of non-contradiction, and law of excluded middle. The content of the law of identity is A is A. This is equivalent to saying it is what it is, which is indeed a tautology. The content of the law of non-contradiction is A is not A. This is equivalent to saying it is not that, which is a double negative in simpler terms. The content of the law of excluded middle is A is either B or not B. For example, a person is either evil or not evil, one of the two. It may seem a bit complicated, but if you think about it carefully, it feels like it applies correctly to anything. However, of these three, the law of excluded middle has even been questioned in modern mathematics, which pursues extremely rigorous logic. What's truly astonishing, though, is that these abstract and fundamental laws of thought were not established in modern times, but were established roughly 2,000 years ago. The person who established them is Aristotle. Upon closer inspection, he is a truly remarkable scholar. Just as it is much more difficult to find atoms or quarks, the elements of all matter, than to find new precious metals, it is extremely difficult to establish these simple elements of logic as laws, rather than imagining complex things like yin and yang or the five elements. While listening to the explanations about the law of identity, the law of non-contradiction, and the law of excluded middle, haven't you thought, what kind of laws are these? In this way, all logical laws are composed of repetitions of these three elements. The logical rules can be seen as a pattern, and all those patterns are made up of these three elements. Therefore, if you want to properly study mathematics, you need to understand the proof process. One of the reasons why adults insist on studying mathematics in school, despite many students disliking it, is to develop logical thinking skills in students. And you should be able to think using the logical reasoning I have explained so far. Therefore, the real way to study mathematics is different from just knowing the answer to a problem. Let's think about the fact that the sum of the angles of a triangle is 180 degrees. Knowing that conclusion is important. It is a universal knowledge that applies wherever there is a triangle on a plane. However, to truly study mathematics, you need to know the proof process. In other words, you need to add logical and systematic aspects to universality. If you organize it to make it visible at a glance, it would look like this diagram. And it's the same in all parts of mathematics. Not only should you memorize formulas, but you should also understand the inference process of those formulas whenever possible. Thus, I have summarized the explanation of the logicality of mathematics. There is much more to explain about this, but I will discuss it in more detail in other videos. Thank you for watching. If it was helpful, please hit the like and subscribe buttons once.